So you do that. Don't burn anything. Oh yeah, we log in with Google now. Anyone still going? Oh, all right. Hasn't stopped you all semester.
We're good? Speaking of no more donuts, who did the donut method? This sum minus that sum. A handful of you? Okay. So if I'm only going from the 6th term to the 38th term, I need to take the 38th partial sum and subtract what? The 5th partial sum. Because I want to start at the 6th term. I don't want to get rid of 6th term. I want the 5 terms below it to go away. So for those, I'm going to need, most of us were fans of the, what was it? S sub n was n over 2 a sub 1 plus a sub n over, what was it? 1 minus d? D? D. Just plain D. Right? What was the formula? They erased it and I forgot it. Oh no, it's just a plus 1. Or it's just the first and the second. That's what it was. Ah, we win. I'm getting it confuzzled with our geometric ones from today. I need n. 2. Why did I just write a 2? I need a sub 1, so I will put a 1 in there and get 3. I need a sub n, which is a sub 38. I stick a 38 in there, negative 150, 40, 190, negative 182. And S sub 5, now I've got 5 terms. A sub 1 is still 3 because I plug a 1 in. And a sub n will be a sub 5. So I should have 5 in there. Negative 25 plus 8 is negative 17. And then sum number 1 minus sum number 2. We'll have 38 over 2 by 3 minus 182 minus 5 over 2 by 3 minus 17. Or, instead, I could just pretend that this is my first term and say n is thing, a sub 1 is thing, a sub n is still a sub 38. That won't change. But if I'm starting at the 6th term, how many total terms do I have? 33. Remember, if I take 38 minus 6, that's 32, but you just got rid of the 6th term. I need to subtract the 5 terms below it. So n is 33. And my a sub 1 is, if I'm starting at the 6th term, plug a 6 in. Negative 30 plus 8 is negative 22. And then I run the formula again, except now I only got one of them. So 33 over 2 by negative 22 minus 182. In either case, where do I end up? I remember it was 3,300 something. Okay. So I don't care which way you took, donut method or pretend method. Either way, you should end up at the same place. Find n when, so this is just formula plug and chug. U. Pink. If I normally have a sub n is a sub 1 plus n minus 1 times d, the formal definition of this. Well, I know a sub n. I know a sub 1. I don't know n. And I can find d fairly quickly. This term minus that term, or this term minus that term, they should be the same thing, negative 17. So I disturb it. Combine like terms, negative 739 is, what's that, positive 17, so 298 minus 17n. Subtract, divide, n is who? I heard a bunch of 61s. Sounds right. Okay. So again, lots of formula plug and chug stuff, maybe a little bit of thinking, but so here's what I'm going to say for the first one. 1 point for the correct information, whichever method you took. 1 point for correctly inputting in the formula. And then 1 for your answer. Whereas this one was a lot simpler. Did you put the correct information in? Did you solve correctly? Because that's just a linear equation from algebra half. What's up?
I used the wrong formula. I used the sum of arithmetic on the bottom one. Would that be 2.5?
The sum of, oh.
Yeah, I plugged it in and I had like negative 79 equals n over 2, 281 plus n minus 1.
So you ended up with a whole quadratic.
I got 579 over 34 plus the root of 234,737 over 34.
So wait a second. When we were supposed to be finding one individual term, you went and found the total?
No. That's not total. That's two.
That was the sum formula. One off for the wrong formula, as long as you solved it correctly.
Did they get their other brownie points today?
Oh my god. I don't have to. Did they get them during finals?
No, they'll get them on Monday with their test.
But if I did the first one, they counted.
Did you write down what you did?
Yeah.
I don't care. You have to write down the formula part of it. The same thing goes for your test on Monday is, yeah, I know you can do a lot of this in your head or just punching buttons on a calculator. Write down what you're putting in the calculator, because that's how you get partial credit. What happens when you don't write any of that stuff down and your answer is nothing like it, but all I see is, here's the problem, here's just a random number that's not right. All right, -5. Because I got nothing to, I literally have nothing to give you. So please, 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 please be careful. What? Oh yeah, because the board crashed. Lars. I didn't get any questions about the homework. It was numerically longer, but because I was just trying to give you like all the different types, I thought they were fairly quick. Is there anything about that formula plug and chug that threw us for a loop? Okay. If we do today right, we should end with 15, 20 minutes. Okay. We're going to finish off 10.3. I'm going to try to show you, just review Pascal's triangle, show you two formulas. That's it from 10.5. Just one of those random things that you might encounter on ACT. So I'd like to show you. Womp. So that's where we left off, was just like you can find sums of arithmetic sequences or series. I can also find sums of geometric series. They've also got two different formulas. The two formulas depend on what information you're given. What is the difference between them? No, in terms of information I'm given. What I need to do the two problems.
The ratio. Ratio and common difference. You need n for the first one.
Okay, they both have a sub 1 and the common ratio.
Oh, okay,
What their difference is one of them knows the number of terms, the other just knows the last term. So this would be, I give you the first like 4 or 5 terms and say, go find the 98th term. Or I give you the formula, sigma notation, and say, go find the whatever. This would be, I give you a term, I give you a term, I give you a term, dot, 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 last term. Just like our example for today, or our daily quiz for today, except it'll be geometric instead of arithmetic. So, round 1, what'd they give us?
Formula 1.
No.
We do formula A sub 1.
Oh, so maybe you should tell me what information they gave us first.
There's numbers. A sub 1 is A. You still need food. You only have food. Shut up, Logan. You still need food.
Just hit him.
Oh, you're giving the formula to the wrong person. I brought him my formula last time.
Just hit him. All right. What information did they give us? A sub 1. What else? No, not in the back of the... It's not D, common difference. Ratio is going to be 14 over 8 or 7/4. Something that came up last hour, be careful. 14 over 8 is 7/4. 24.5 over 14. Is it still 7/4? It does say common ratio, meaning they have to have it in common. If it doesn't have a common ratio, then it's not even a geometric series. So you can't do it. Okay, so just watch that. And then they gave me n. They said find the sum of the first 6 terms. So, plug and chug. S sub 6 is, given that information, I have enough for, yes, formula 1. Okay, so we're going to say A sub 1 times 1 minus r 7/4 to the nth power was 6. 1 minus 7/4. I'm jamming in my calculator, I find stuff. Now, someone usually tries to freshman math this. If you do this, we got problems.
Killed a puppy.
Like, I've seen kids try to do it. No, if you have like 5 plus 3x over 10, and you try to do this, you just killed a mathematical puppy. You should feel terrible about yourself. Okay. So, press the buttons, and if you type it in like this, instead of saying 1.75, if you actually say 7/4, it should spit it out as a fraction with our calculator. It's going to be big and ugly, but it should give us a fraction. What do we got? 3785 what? Over. which is about
295.
0.711. Okay. So I'm given the information, I find the formula, I plug the things in. Round 2, what information am I given? Well, that, right? So I've got enough to do the second formula. So we're going to say S sub n, I have no idea what n is, and I don't care. 3 minus a sub 1 times, a sub n times r is 768 by negative 2 all over 1 minus r, negative 2. 1400, 1520, 1536, 1539 over 3, 513. So, formula plug and chug. Get them. One of each. I said the last chapter is easiest. Now, when you start to get into the proofs that these series can create, proofs of discrete mathematics, I ain't gonna lie, that's one of the things I don't even like. But I also got a sour taste in my mouth about that because of the instructor I had for it. You know, many kids come up to high school thinking that they're bad at math or they just hate math, and it's really because their teacher was horrible. Or worse yet, they get the familial reinforcement. Their parents saying, well, I'm not very good at math either. So then they think it's just genetic. Like, no, it's not. It's not.
Chad, did you have Miss Moore? Miss Moore?
I did.
Yeah,
I
seventh
did.
grade.
Very bad. She told me that I was one of the kids that just barely made accelerated math.
She was called Ben.
Let's
Talk about her ex-husband.
let's back that up. There's no such thing as accelerated math in middle school.
Middle school. Yeah, that's what I got.
So tired of kids coming up to the high school and their parents are like, but they were in advanced math for so like there's no such thing as advanced math in middle school. It just means that you were good at basic arithmetic, so you were ready to start pre-algebraic concepts. It's not advanced, it's more like this is what you should be doing and these are the kids that are held back. Yup. Just like there's a lot of kids who come into our algebra half instead of algebra 1 purely out of maturity reasons. Oh yeah, these are geometric series. Geometric series are going to get very, very, very large or very, very, very small because they're exponential. Exponential functions, well, they always had a end behavior of plus or minus infinity, or converge to a asymptote. So sum of the first 11 terms. So I've got S sub 11 is a sub 1, right? A sub 1. Yep. 7 by 1 minus, so 5, 3 and a half, 3.5, 7 halves. Yes. To the 11th. And round 2, going to have S sub n is, I know a sub 1 and a sub n, so negative 8 minus 1, 1, 0, 2 to the negative 4 over. Okay. Check your formulas. Check my formulas. Good? Sweet. All right, let's see if we can all press buttons correctly. First one, what do we got for a sum?
1,537,922,393 over 1,024.
That is not what I got. Oh, maybe as a fraction, but as a whole number, I got 150,1877.
Yeah, okay, that's what it is.
0.337.
Point.
0.337?
0.3. Yes.
150,1877.3.
Okay.
One 877.337. Yeah.
For one man, it's a real number. It's not a whole number. Yeah,
It is a real number. It is a rational number if I write it like that. But, ew. And round 2.
1,048. Kind of.
Just that?
Yeah.
Oh, that's nice.
That's a whole number. That's a good number. That's a whole number.
That is a whole number, yes. What's the, I just heard it. Okay, if you want to get as specific as possible, it is a natural. What's the difference between natural numbers and whole numbers? Just the difference is 0. Remembering all the way back to our very, very, very first lesson talking about sets. Okay, finding them in sigma notation. Just like with our arithmetic series, you can decide to either do the donut thing or just pretend that that's your first term. Your choice. If this starts at 1 instead of something else, remember this is r and this is a sub 1. Because that's the form of it. A sub n is a sub 1 times r to the n minus 1. That's the form of it. So if I'm told to find a sum from sigma notation and it starts at 1, I am definitely using first formula because it gives me everything I need. Oh, this is n, right? But this doesn't. It starts at 2. So I either need to find the 7th partial sum and subtract what? The first term, because I'm starting at the second. Or I can just pretend the second term is my first term. Your call. Okay. Most of the group was all about saying, I'll say n is 6. 7 terms minus the 1 term I don't care about. And I would say my a sub 1 is plug 2 in there because I'm going to start at the second term. Okay. And r is still r. Option 2. Okay, even using this, remember I've got two different formulas I could use. I could say my second formula, a sub 1 is 15, r is still 5, but now I would need a sub n, which is going to be a sub 7. Plug a 7 in there. 7 minus 1 is 6, 5 to the 6, 5, 25, 125, 30, 125, 15, 6, 25, 30. No.
Yeah.
3125, then.
Maybe you typed it in wrong. Maybe you don't have the order of operations right. 5 to the 6.
No, I'm getting to the 6th one. I started at 5 and now I'm getting to 6.
5 to the 6 is
5 to the 5th is 3125, and then someone interrupted me.
Yeah. You already said it. You said 16.25 before, and then you went 31.
No,
You did.
What's the number?
46, 835.
Someone confirm this. I don't trust Logan.
Sure.
Someone confirm this. I don't trust either of these two clowns. Okay. All right. And then dump it in your formula. Okay. Now, do you see why I would much rather use the first formula?
Yes.
Because they both involve the same amount of information. But the second formula, a sub 1 minus a sub n times r over 1 minus r, that one requires finding a sub n. Well, what happens when a sub n is a big long decimal train that I can't write? What happens when a sub n is a ridiculous fraction like some of the ones we've gotten already? I don't want to rely on something that might have a round-off error. So that's why I stick with the first formula. And I'd say S sub 6 is, first formula, a sub 1 times 1 minus rate to the nth power over 1 minus rate. Okay?
58590.
I heard 58590.
58590.
Yeah.
Okay. I don't see a need to do both of them. Let's just do 7b.
You already know. Can you check my work now?
Seven plus one because you use and then you get plus one because you're getting rid of one anyway.
I guess. Yeah,
4, 1, 3, 1/2 to the third, 1/8.
and it's because of order operations. order of operations.
Is that 15 again?
Or not order of operations. So
120 over 8.
for them, they put a 1.
All right, 4, 1, 3, 1/2, 1/8. Divided by 8 is 15.
Well, I mean, but it's minus 1. So it's 1 minus 1 is 0. That's how I get 60. So that'd be wrong.
Yeah, you guys are wrong.
So with 4, ace of 1 is 15. It's 15. Yeah.
Yeah, we're right.
Or, wait, would you put a 1 in there?
Why would you put a 1 in there?
Because if it's ace of 1, then n is 1.
Oh, N's 4.
I mean, it depends.
Okay, I got it.
Okay. I think. What else? Numbers. Yeah.
Because you want that with
6, but it's not the same. Okay, we need
Oh,
the same
yeah.
numerator.
Yeah.
Now we plug it in.
If I start with the fourth term, if I pretend the fourth term is my first term, so I don't have to do the donut method. If the donut method was your jam, do it. Just start plugging numbers in, find S sub 11 and subtract S sub 3. But if I'm starting at the fourth term, you have to remember you are subtracting away the first 3 terms. 11 minus 3 is 8. And if I'm starting at the fourth term, I have to put a 4 in for n to get my, air quotes, a sub 1. Getting 1 over 5. 2, 8, 26, 5, 128, 256. 1 minus, so 255 over 256. 1/2. So 255 over 128. 2550. And 5 by 2150, 3150. Crap, lost it. Like 3,000 something over 128. 38 who what?
2, 5.
Or a boot, 29 and change. Okay, so it's just more formula, plug and chug, new type of formula. Then we run across this before. What if I said, tomorrow I will give you $100. And then every day thereafter, I'm going to give you that plus half as much as I gave you the day before. Or what if I just give you half as much as the day before? Not that plus. So the first day I'll give you 100. Second day I'll give you 50. Third day I'll give you 25. Fourth day I'll give you 1250. And on, and on, and on. What happens eventually?
0.5 cents.
I'm giving you belly lint. Like, it's so close to 0, but not 0 itself, that I'm practically giving you nothing. That's why, to find the sum of an infinite series, the formula only works if the common ratio is a proper fraction. Because what happens when I take 4/5 times 4/5 times 4/5 times 4/5, and I just keep doing that? What happens when I take 80% of 80% of 80% of 80%? Over and over and over. Okay, what happens when we fruit ninja Nick and cut him in half and in half and in half and in half over and over and over and over and over? Eventually, no more Nick, just Nick soup. Okay, right? So if it's a common ratio, or if it's a proper fraction for my common ratio, then this works, because eventually I'm not saying I'm going to add up an infinite number of terms, I'm going to add up almost nothing. Eventually, I'm adding nearly nothing. And that's because when I take that first term plus that infinity term, and then that second term and that infinity minus 1 term, and that third term and that infinity minus 3 term, and when I smash them all together, it becomes this. Remember that trick for like adding up all the digits? Add up all the digits 1 through 100?
Oh,
Yeah.
it's like the,
That was articulate. What's 1 plus 100? What's 2 plus 99? 3 plus 98? 50 plus 51. So just take one of those sums times however many of them you'll do, it ends up being 101 times 50, which is 50-50. Okay? When I do that, that's the concept behind the proof for this, is that if I take almost nothing plus term all the way to half of that, I get super easy formula that only works if my common ratio is the right size. So, find your common ratio. What's 3 divided by 9? Double check it. What's 1 divided by 3? Okay. So if r is 1/3, then formula says the sum of an infinite series, I know some kids would like to put a sub-infinite there, just so they remind themselves of the formula. A sub 1 over 1 minus r. Be not afraid of the fraction. You do not need a calculator for this. What is 1 minus 1/3?
2/3.
And dividing by fractions is easy as pie. You still use the calculator. Oh, okay. As soon as you hit the clear button, it's gone.
No.
I don't trust you.
Last thing I put is 100 to 1.2.
If I take negative 1.25 divided by 0.25, what do I get? How about 5? What is 6.25 divided by negative 1.25? Is it actually?
Yeah.
Okay. My common ratio is not a proper fraction. It is not an absolute value less than 1. So that means sum of this infinite series is not possible. And we say it's not possible because if the number is constantly getting bigger, especially when it's being multiplied by a negative, by a negative, by a negative, you're saying at the millionth term it's positive gigantic. But at the million and first term it's negative giganticer. And then at the million and second term it's giganticer. And then you get in, it keeps oscillating further and further out. It becomes that argument on the playground. You know, yeah, well, I got a bazooka. Yeah, well, I got a nuclear weapon. And yeah, well, I got lasers. I got a dinosaur that eats shields. And it spirals out of control because you can't find that sum. What's r in this? It's right there in the formula, 0.2 or 1/5. Now, you got to be careful. It doesn't say to start at 1. So I'm not using 4 as my a sub 1. I'm not starting at the first term. I'm starting at the fourth term. So S sub, it is still infinite. It's just I'm starting somewhere else. Is going to be a sub 1 is actually a sub 4 because I'm starting at the fourth term. So shove a 4 in here. 4 minus 1 is 3. What is 1/5 to the third? 1 over 1/25. And times 4. My first term is 4 over 125. over 1 minus r. R is 1/5. Be not afraid of the fraction. What is 1 minus 1/5? Dividing by fractions is easy as pie. So what is 1 over 25, because your 4's will cancel, and 5 over 125 becomes 1 over 25. Or jam it in your calculator, right? If I get 1 over 25, isn't that also 0.04? Okay, same difference. So it's a new formula, but it's a formula that can only be used under certain circumstances. Go.
That's what I was thinking. That's where, yeah, that's where I'm not done.
Are you sure you guys added 1/2? Yes, so I got 3. I did 15. It doesn't work. It's using 15 by 3/4, so it's not 10. It's like 40 over.
Remember what I said? Not only do you have to see if your common ratio is legal, you have to see if there even is a common ratio. 15 over 20 and 10 over 15 are not the same thing. 8b is not a geometric series. What is it? It is an arithmetic series. Okay. No, it's not. So, That's the end of that. Y'all remember our friend? Okay.
Thank you, Pascal.
So Pascal's triangle's got a lot of stuff going on in it. Okay. In every single row, 1, 11, 121, 13, 31, 14, 641, those are all powers of 11. Each row is a power of 11. The sum of each row is a power of 2. 1, 2, 4, 8, 16, 32, and so on and so on. There's other things in there. The hockey stick numbers, I think they're used for Euler's. Well, Euler did a lot of stuff. I'm pretty sure Fibonacci sequence is hiding in there. Like, there's a lot of things. Okay. So when I say the 6th row of Pascal's triangle, know that I'm talking about that yellow row that starts with 1, 6. Okay, the one at the very, 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 very top doesn't count. Call that row 0. All right? Because this is used for expansion of binomials. Do you remember how it's done? 7, 21, 20, 25. Okay, if I want to expand this, I start with all of those coefficients from the 7th row of the triangle. And I'm going to put a set of parentheses next to each of them so that I have all of my spaces for my A and B terms. So let's start there. 1 parenthesis parenthesis 7 parenthesis parenthesis, or if you are a veteran of algebra 2, butt cheek butt cheek. Okay, because it's not always that easy. We're talking about the process now for when it's not easy. Do you remember what I do with all of my A terms? And then descending order. A to the 7th, A to the 6th, A to the 5th, to the 4th, 3rd, 2nd, 1st, 0. And for the B terms, ascending order. B to the 0, B to the 1st, B to the 2nd, 3rd, 4th, 5th, 6th, 7th. Specifically, look at what the exponents, the degree of each term, total up to. Because it is a 7th expansion, every single term should have a grand total degree of 7. And then I have to simplify it. Now in this case, if I just get rid of the parentheses and call B to the 0 and A to the 0 ones, it is simplified. The reason we have to know that process is because it's not always that easy. Because sometimes it's not just A and B, there's numbers in there. So, go to the 4th row of your triangle. 1 parenthesis parenthesis 4 parenthesis parenthesis 6 4, right? Yeah. I said the very, very top is row 0. Yeah. Okay, so I write out my coefficients and all the butt cheeks. That is brought to you courtesy by the front row of doofuses from last semester's Algebra 2. I said it once and regretted it because for the rest of the semester, in the final, while they're taking the final, I hear someone in the back corner, butt cheek, butt cheek, butt cheek, butt cheek, butt cheek, butt cheek. Okay. So, I'm going to put 3x to the fourth, 3x to the third, 3x squared, 3x to the first, 3x to the 0. I'm going to put 2 to the 0, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth. And then, order of operations. I will see kids year after year, all the way into pre-calc, say 6 times 3 is 18, 18 squared, and then multiply by 4. Don't do that. If you need to, it would not be a bad idea to just make a second line where you include those simplified values, times 81x to the fourth, times 27x to the third, times 9x squared, times 3x times 1, times 1, times 2, times 4, times 8, times 16. If you need to do that, do it. And then simplify each one. 81x to the fourth, 492, oh, that's 216 because it's 6 cubed. Plus, that's 333, that's 216 again. All right, plus, that's 24296 x plus 16. Okay. Do you remember this? Like, is that enough to knock the rust off of that particular gear in the back of your head? Okay. So, instead of doing a whole bunch of those, y'all remember this. Cool. Notice that this is a thing plus a thing plus a thing. It's a series. And it's a series that is created in a very specific way based off of Pascal's triangle. Pascal's triangle is based off of probability and the number of arrangements that I can do things. So the binomial theorem, we mentioned it in Algebra 2, but we never actually gave you the theorem itself. The binomial theorem is when I combine all of the things. I take combinatoric probability. Remember that from all the way at the beginning? What's the probability that I pick exactly 3 sophomores, 2 juniors, and 4 seniors for my group? You take combinatoric probability plus all this stuff about sequences and series that we've just been learning, and you prove it. That it turns out the coefficient in every single one of those lines of Pascal's triangle, every one of these coefficients, hey, get back here. Where are you? There you go. Every one of those coefficients was just NCR, a combination. And we all have the NCR button on our calculator. Y'all remember where it is? Math and probability menu. If you have alpha shortcuts, alpha window, it is on there because it happens so often. Okay? So if I'm trying to find a very specific term of this expansion, I get to just use the combination. Okay? Now, there's more to it. Again, more proving. Substitute this in here. Simplify that. Blah, blah, blah. I'm not going to go through the proof. I need you to highlight way down here. R is, remember R and NCR? So this isn't R as in my common ratio. This is R as in if I want the kth term of a sequence, kth term, they use k because n is already used. Remember, it's the nth expansion. So I can't say the nth term, so they use k. I don't know, they just like k. Insert social commentary here. So when I'm going to find the fifth term of an expansion, next to this, I would like you to write that finding the kth term where k is 1 minus r. No, not 1 minus r, r minus 1. Okay. Because remember that as I was going along my list, the a term and the b term, when I was expanding, the b term started at 0. It was the first term, but it started at 0, right? B to the 0. Okay. If I'm trying to find the kth term, oh, did I do it backwards? I wrote it backwards. Did I? Yeah, I did. Okay. Yep. Keep going.
Another 22. No.
Where
We have 6.
Oh, wait.
Yeah, we don't need. No, we have 7.
Oh, we're.
r is k minus 1 instead of k is r minus 1. Okay. Of a plus b to the n is NCR a to the n minus r b to the r. It is a formula. Okay. It's just a formula. Where now I don't need to write out the entire Pascal's triangle to find a specific term. If I say I just want you to find the 7th term of blah, 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 blah to the 11th. I don't want to go all the way to the 11th row of the triangle. Now I can just plug junk into the formula instead. Now, again, you see as the numbers go further down the triangle, they get pretty big. But y'all got formula? Okay. That's literally all you're writing for this example. Because this example is easy peasy. It's just A and B. What happens when it done get gross? Okay. They said find the coefficient of, we're going to find the whole term anyway, this term. Well, the nice part about that, remember, NCR times a to the n minus r, b to the r. Well, if they said find the coefficient of x to the 7th, y to the 2nd term, they're telling me those two, right? Because I'm going to have x to the thing is going to make x to the 7th. Y to the thing is going to make y squared. So they're just straight up telling me that r is 2. What else do I know? 9th expansion of a thing. So I know n is 9. And I know my a and b term. A is 4x. B is negative 3y. Plug and chug. If you want to know that specific term, now you got a formula. 9 choose 2 times 4x to the 7th and negative 3y to the 2nd. Now we already know that it's going to end up x to the 7th, y to the 2nd at the end. But can you take 9 combination 2 times 4 to the 7th times negative 3 squared? It's going to be big. It's going to be big. And that's the point. I want the formula to find big thing instead of having to go all the way down there in the triangle and find all of those different terms. I don't want to find all those terms. I just want to plug and chug on one thing. What do we get? 530,841. Okay? You get big. So, it is just a formula. That's it. It's just a formula that helps you find a specific term. Now, what we need to be careful about is, I'm not even going to bother with these. We're just kind of ripping through them here. What they want us to do, nope, not that one. What they're going to want us to do eventually, and I think it's the very last example, writing the binomial using the binomial theorem. If you don't like coefficient butt cheek all the way across, you can do formula for every single term. And every kid that I've ever had in class says, if I got to do it for all of them, I'll just do the regular triangle thing. Seems faster. And they're right. The formula works really great for finding an individual term. It sucks for finding the whole thing. I just wanted to show you the formula. The formula can also be written, blah, 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 math, to find what's called binomial probability. Binomial probability is when there's only two outcomes. Either you win or you lose. Where's my baseball kids? There's always at least one. Uh-oh. What's your batting average?
Not good.
100?
No, about that. Like,
We'll give him 250.
yeah, 250.
Really?
I play baseball with him.
Not 250.
It's not horrible.
That's not bad.
No.
Like, okay, if anyone knows, batting average is probability of a hit. It's percentage. So if you're batting 300, it means you're going to hit 3 out of 10 times. Okay? And even professional athletes, like 300, 350, okay? That's like bonkers good. If anyone's batting 500, they're an alien. All right? So 250, you said? All right, we'll call it 250. So what this says is the number of trials, choose the number of successes times the probability you succeed, and you will succeed this many times, and the probability you fail times n minus f, or n minus x is trials, no, how many are going to succeed, right? Yeah. Trials minus success. Okay, that's what that formula means. It's saying if Will's batting average is 250, that means he has a 25% chance to hit the ball every time. You don't hit the ball or kind of hit the ball. You either hit it or you don't. What happens after that, well, that's a different story. But he has a 25% chance to hit the ball. I would ask something very specific. Like he has a 25% chance to hit the ball, and he's going to be at bat 20 times this month. What is the probability that he hits it 8 times? It's a yes or a no, and I'm looking for a specific outcome. That's binomial probability. So I would say Will is at bat 20 times, and I want him to be successful, hit the ball 8 times.
Does that just mean hit the ball once? Get a hit.
Get a hit.
His batting like session.
So
Okay.
20 times at bat, he hits ball 8 times. Probability that he's successful was 0.25. I want him to do that 8 times, right? If your chance of being successful is only 1/4, doing that 8 times is going to be very lower. But I balance it out by saying he's going to fail that many times. And then I jam it in my calculator. Okay, so 6%. Remember, you're looking at a very specific thing. If someone's got a batting average of 25%, you're asking what's the chance that they actually hit it instead 40%. Shouldn't that percent chance be fairly low? Because it's above their current rate. Yes?
Do you want us for these to write down percent? Do you want us to take it times the 100 and then write it to 3 decimal places? Or do you want us to?
I always do 3 decimal places and then turn it to a percent.
So just 6%.
Yeah. So I'd say, what was it, 6.1?
Yes, exactly.
Okay. Now, this is starting to lead into, has anyone heard of a hypergeometric calculator? Okay. You got to be a super dork to get into those. Magic players. Hypergeometric calculation is used to determine how many of a particular card that I want in my deck to achieve a particular effect. There's statisticians who will work on Pro Tours for that kind of stuff. Or you could just Google hypergeometric calculator and put in, I want this to happen, I got this many things, and it'll tell you what you need, okay? What those do is, I would do this formula for he hits it 8 times. I'd do it again for he hits it 7 times. I'd do it again for he hits it 6 times, 5 times, 4 times, all the way down to 0 times. And then, because those are all discrete events, they do not happen at the same time, I add them all up and say, Will actually has a this percent chance of hitting the ball 8 times or less. That's when you start combining all of them. Okay, so it's a formula. You can use it. It's really cool when you head into stats. Try one of them. Just formula plug and chug. What is N? What is R? What's the probability of succeeding? What's the probability of failing? How many times do you want to do it? Plug them in the formula, dump it in the calculator. What's the probability he's successful?
Oh, 0.2.
0.2 or 1/5. So what's the probability he fails? 4/5 or 0.8. I want him to be successful this many times. That means he will not be successful that many times. I jam it in my calculator, and it's not going to be very high. Because think about this, 4 hits out of 10. 40% hit rate, where his batting average is 2 out of 10. So you want him to hit the ball twice as much as he normally does. What is the chance that this occurs? Less than 9%? Okay.
Half of that.
So it's just a formula. I bring this up because y'all are at the end where you got to decide what you're doing after here. PreCalc, I said we're trying to get you ready for the next 3 classes or more. I say or more because there's a handful who are not headed into a STEM field. From here, you would probably be best going to college algebra and stats, getting the easy A's, and now you're done with math for the rest of your life. Well, you're going to use math, but because a lot of schedule talk has been happening, you know, with that Tuesday's schedules being handed out. Again, if you are headed into a STEM field, STEM, science, technology, engineering, and mathematics. If you are headed into those fields, or mathematics, medical words, I just like math. If you're headed into any of that stuff, you want to be a nurse's assistant. You want to be an RNA. You want to be a
The N does stand for math.
It is mathematics.
I think.
I think they might have changed it.
I think medical falls under.
Yeah, I don't.
Whatever. They changed it.
Oh, and we changed it.
Change it to medical. What's the A?
Arts.
Yeah, I know. I knew that one.
Okay. I mean, you can, because like you can get into fractals, you can get into pointillism, you can get into compression and expansion of pigments, you can do a lot of graphic arts. Stuff revolves around mathematics, so I get that. If you're headed into a STEM field, after taking this class, you should be testing out of college algebra. It would be a waste of your time. Just take the test or your ACT score, and they will plug you into Calc 1 or 2 instead. If you're not headed into a STEM field, then after this, go get your easy A's by dual credit when it's cheaper, and now you're done with your generals for math. Okay? But we're trying to get you ready for potentially college algebra, stats, discrete math, trig, and calc. This is just one of those random grab bag things that they would like you to at least see or be exposed to. All right? Remember, Monday, last quiz, last chance to turn stuff in. Unless you have had a conversation with me. Monday is the last day that I will accept any daily work. Okay? Yes. That is the last chance, unless you have had a conversation with me.